Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have two integrals for you. The first one is this one here. It's the integral of 4x plus 3 all over 4x squared plus 6x minus 1 dx. Now how do we approach this? We're looking at the denominator, differentiating the denominator with respect to x. We're going to have 8x plus 6. Looking at the numerator, we have 4x plus 3. That means we must multiply the numerator by 2, but in doing so we shall have changed this integral. So we don't want to change it. So we multiply by 2 and divide by 2 at the same time, as follows. Here is the story now. Our first integral. It's the integral of 4x plus 3 all over 4x squared plus 6x minus 1 dx. Now what I was saying is this is the same as multiply by 2 divide by 2 at the same time. The integral of 4x plus 3. When I fix this one up, it doesn't look very nice. It's supposed to be 4x plus 3, and we're dividing that by 4x squared plus 6x minus 1 dx. Fantastic. Now the 2 goes into the integrand. What do we have outside? We have 1 over 2 times 2 open brackets 4x plus 3. We're dividing this by 4x squared plus 6x minus 1 dx. Distributing the 2 in the numerator, we have 1 over 2 times the integral of 8x plus 6 all over 4x squared plus 6x minus 1 dx. Fantastic. At this stage, I'm going to let u be equal to the denominator. Let u be equal to the denominator, which is 4x squared plus 6x minus 1. Differentiating with respect to x, on the left we're going to have du, on the right we're going to have 8x plus 6 and then dx. Now if I change this integral a bit, it will change as follows. I'm transforming that integral now to this integral. I'm going to transform it so that it looks a bit different as follows. Watch carefully here. I'm saying that integral is the same as 1 over 2 times the integral of 1 all over 4x squared plus 6x minus 1 multiplied by 8x plus 6 dx. Why am I doing this? Well, because if you look at this one here, is exactly what we have over here, is that expression there. So now I can transform that integral as follows. This integral therefore is transformed as follows: 1 over 2 times the integral of 1 over u times du. Remember, u is equal to 4x squared plus 6x minus 1, and du is equal to that expression. Now you'll agree with me that this is just half times the natural log of u, and then we have to say plus the constant of integration. Now looking at the variable x, we have to revert to variable x because we have variable u here. Reverting back to variable x, we have the connection between u and x is 4x squared plus 6 x minus 1. So we are saying this is the same as half times the natural log of 4x squared plus 6x minus 1, and then we have to say plus c. Now if you do not want this half here, using laws of logs, it will be the square root of this. In that case, you don't have to use absolute values. It will be the positive square root of this expression. But otherwise, if you want to leave it like this, you must maintain this because this expression here can be negative. It can be negative. By completing the square of this, you'll see that for some values of x, this expression is actually negative. So we have to maintain the absolute values, and therefore this would be our final solution. But like I said, if you don't want the half, you can say it will be natural log of the square root of this and then plus c. But I want to keep it the way it is. It's just as fine, just the way it is. Right, so this is the solution to our first integral. Just to remind you, our first integral is this one, or was this one. Let's look at the second one now. The second integral I have for you in this one is the following. Definite one. Here it is. It's the integral from e up to e squared of 1 over x times natural log of x dx. The approach is as follows. Let's capture the integral number 2. It's the integral from e to e squared of 1 over x times natural log of x dx. I'm going to combine x and dx as follows in my next step. From e up to e squared, 1 over natural log of x times dx all over x. At this point, I'm going to let u be equal to natural log of x. Differentiating both sides with respect to x, you're going to get du, and keeping dx on the other side, it will be 1 over x dx. Now this can be rewritten as dx over x, which is exactly what you have over here. So that's the first connection I have. Du is equal to this. Then I have to change the limits of integration because our original variable is x, but now we're changing to u. So changing the limits of integration, we need this equation here. So we're going to say as x approaches e, the lower limit, what does u approach? U must approach the natural log of e. We put e in that place. Remember, that's the connection between u and x. What is the natural log of e? The answer is 1. And as x approaches e squared, the upper limit, that one there, what does u approach? Well, u approaches, I want to get rid of this one here. I want to write u there. As x approaches e squared, u must approach the natural log of e to the power 2. We're taking this into that place, remember? And by using laws of logs, this is exactly equal to 2. Now that's the upper limit of our integration. Now let's change this integral therefore as follows. Taking us to the last page. So, and let me put these papers in order here. So basically I'm saying to you that integral now, which integral? Therefore, the integral from e up to e squared of 1 over natural log of x times dx over x changes to the integral from 1 up to 2. Remember, the limits of integration are 1 up to 2. As you can see here, the lower limit 1, upper limit 2. But now I have 1 over, remember, natural log of x is actually u. There is natural log of x is actually u. So I put u here, and in that place I'm going to have du. So 1 over u du. Now, the integral of 1 over u, you'll agree with me that this is just natural log of u. But we're evaluating it from 1 up to 2. So this is natural log of 2. No need for absolute values because 2 is positive, minus natural log of 1. Natural log of 1 is 0. Our final solution is natural log of 2. That's our final solution to our second integral. Let me just show you the second integral we've looked at so far. Is this one here. Right, this was the second integral we had to work on. Now, tell me what you think about these integrals. Very straightforward. Yeah, I hope you found these two integrals useful and my approaches useful. I'll see you in the next one.